So just so I understand, I'm talking since I was planning to do this freeform, can we just do an introduction so I know who I'm talking to as far as skill sets? Is that possible? I'm going to start with you, since I know you.
Yeah, Ethan Banks, network architect, CCIE, that kind of guy. Yeah.
Gotcha.
And Henry, senior engineer for regional education in Connecticut.
Okay.
Hans Lin here, storage blogger.
Storage blogger, okay.
Jason Edelman, work for local VAR, and I'm a network guy.
Network guy, okay.
I'm Greg Farley, packet pushers.
Hi, I'm Greg. Good to see you again.
I'm Gideon Tam, networking folks for Cancer Hospital. Cancer Hospital,
okay.
Edward Ledke, and I'm a virtualization cloud person.
Virtualization cloud person, okay.
Technologist.
Okay.
Tom Hollingsworth, I am a reformed networking guy.
Reformed.
Good for you.
Born again?
I work for him now.
Nice, nice. So there's a lot of things we could talk about here. I didn't have any slides, like I said, when we started. So it was more of a discussion about trends, I guess, we're seeing in several standards we could talk about, as well as functions that we're seeing being simplified, right? So in a lot of environments, you guys have heard of overlays, I'm pretty sure, right? We're going out there. We've seen a lot of overlays being pushed because there's IP cores in the middle, and those environments, it makes a lot of sense. What was interesting is, as Greg and I have talked in the past, Ethan, you as well, is that we've watched data centers evolve in a need where they needed VM migrations, and we'll just kind of start there and move into some other area aspects. I think what's interesting is too many people think that that's the only problem in a data center is a vMotion, and it's not, right? I think most of you realize there's obviously storage issues, there's obviously VM issues. The problem, not all data centers are actually virtualized yet. There's appliances, there's mainframes, but then you also have different services that need to talk to each other. So what we found in standards and even in deployments is that most people weren't really just simply trying to do a vMotion for vMotion's sake. They're doing it because they're trying to solve a viral application problem, and they needed the agility just to be able to do it when they want. So that was one aspect of why we invented shortest path bridging in the IEEE. And by the way, it's also RFC 6329. It's both an IETF and an IEEE standard. It's not just an IEEE. And pretty much all the work we've been doing in the IEEE, by the way, is all been based on shortest path bridging. Where we're seeing it used is actually kind of interesting. It's deployed in pretty much every major vertical in every single major market, right? And I'll give you an example. There are stock exchanges who use it right now to speed up the communication between trades, right? Not just as a LAN technology, but actually as a routing protocol as well. There are hospitals who are using SPB right now to simplify the campus environment across multiple hospitals around many different states. In fact, the large hospital system throughout the Midwest, where the entire network looks like one virtual switch router, and they're able to reconverge the network in 20 milliseconds. So this is not only providing data center access, it's actually the network providing connectivity from the MRI all the way back to the server in a data center. From the doctors who are trying to watch videos of surgeries going on to the nurses walking around in crash carts, they're all connected to the fabric, right? And it's able to keep every one of those services completely isolated from each other. So a kid sitting there in a hospital visiting grandma on wireless LAN is completely invisible to the MRI network. Their virtual networks completely run up separate, but on the same physical network infrastructure. Right? So real multi-tenancy, essentially. But now a lot of people say they can do that as well. The question is really, the functionality I'm referring to is typically assigned to protocols like MPLS. We're not saying you need to do MPLS to do this. You can actually just do this on SPB. Right? You don't need to run all the complicated protocols inside of a campus or right to the top of rack to get VRRPs and all that functionality. You just run SPB and you get all that functionality built in. Right? So even here at Interop, that's exactly what we're doing here. Right? So the entire show floor here at Interop and the one in Vegas as well was completely run just on SPB. There's no OSPF, there's no spanning tree, there's no BGP, and there's no PIN. Yet we have VRFs running, we have IP multicast running, right? We have vendors getting access to the internet over their private connections. There are actually virtual machines bouncing around the environment, and whenever we need to turn up a new service, it's simply just configure for our box, it's actually a 5-word command. You just say ISIG 7 VLAN 2, and you're done, or VRF blue ISIG 20, and that's the VRF config. Right? Really nice and simple and easy. You don't have to go through complex multi-tiered protocols to make things work. You don't have to worry about putting simple Ethernet into RDP, into IP, into UDP, onto just simple Ethernet again. Right? It's just on the basic Ethernet layer. And then IP is aware of everything underneath. Now, expanding upon that, it's interesting to see the applications where multi-tenancy, I think, is taking on a life of its own, quite honestly. It's also got a hype of its own. And the hype of its own is the one that's driving me nuts, to be personally honest, right? The question is, what does multi-tenancy really mean? I think it means a lot of different things to a lot of different people. And everyone I talk to has a different use case and different background in mind, that they don't quite recognize that their view of the market is not this other person's view of the market or this other person's view of the market, but they're all using common words and they think they're talking about the same things, right? Is this resonating with you guys? Right? I see this all over the place wherever I go. So a tenant to, say, a service provider is not necessarily the same thing as a tenant to a CIO of a hospital, right? To him, his tenant is the MRI. It's a device. And a manufacturing floor where SPB is running, the robots that are building the cars are one tenant compared to the human beings doing maintenance on them on a different virtual network on the same physical infrastructure, right? Again, just one Ethernet IP protocol. So the people troubleshooting it don't have to go through a mountain of education to relearn everything they knew about Ethernet over a complex set of protocols. It's just Ethernet, it's just IP. It evolves with them in their own education, and it's easy to understand. It's an evolutionary kind of approach.
Quick question, how
Yeah.
deep does this go? I mean, you're talking physical, does it actually have any virtual components as well?
The entire functionality of SPB is about virtualization. What SPB does to the network.
Do you have any virtual components in the hypervisor? Let's be very clear about that.
Oh, I see what you're asking. Again, semantics. You said virtualization, I see virtualization is slightly different. Okay, so in a hypervisor, there's multiple hypervisors out there. We're actually
Yes,
working.
5 of them.
Yeah, exactly. All right, so not all of them will have it, but all of them can connect to it because they can all do VLANs.
Well, how many will have it?
How many will have?
SPB?
How many of them have spanning tree?
None of them.
Okay, how do they connect to a spanning tree environment, or even to that point, any kind of environment, IP environment? They
Most
use,
of them just ignore spanning tree, to be honest.
and they use IP and Ethernet, right? So in every environment, and every that SPB is deployed in, there are every one of those 5 virtual machines, or excuse me, virtual switches connected into the environment, and they use IP and Ethernet to connect in.
No, that's not what I was asking.
Okay, what are you asking?
I could care less how it's connecting over in physical networking,
What
which
do
is
you ask?
exactly what you're talking about, which is I'm asking about if I'm going to put this on my Ethernet into SPB into my physical plant,
Yes.
why not extend it into my virtual plant as well
Scale.
by having a special, its own switch, whatever
Yeah.
you want to do?
So we are actually working in standards about putting into OVS, for example. So that's actually one thing that is coming. My personal worry about that, though, is that we never put OSPF into PCs.
This is not a PC. You're talking about a system that can
I
run
know.
300 to 1,000 VMs themselves.
But you're missing my point, all right? My point is a scale, link state, and how it stretches out, all right? In the largest of service provider environments out there, they don't always run their routing environment all the way to the edge. Sometimes they stop at one hop away from the edge for multiple reasons, security and different things, okay? Can you do it? Absolutely. Will we allow to do it? Absolutely. I'm just saying, don't think it's a bread and butter, do it all the time,
Okay.
all right? It's engineering at engineering's heart. It's understanding the limitations and the ask, and making sure that both meet up with what's required. Because sometimes you have engineers who want to do a whole lot, and there's security people in the middle saying, "Oh hell no, right? I don't want to provide something like that." Now, does that apply to your environment? Probably not, because it looks just based on the way you asked the question.
Well,
But there are other environments.
put some use case around that. You've talked about SPB perhaps getting extended into OVS.
Mhm.
What was the driver for that conversation?
The one in the OVS is actually kind of interesting. Pretty much to the point you're coming up there, right?
OVS isn't actually part of any virtual switch today.
Okay, so but keeping it to a simple virtual switch, is having the ability that the systems managing the vSwitches themselves would have the ability to signal to the fabric that I have X number of VMs that want access to this particular LAN or this VRF, right? And let the machines in the SDN kind of approach configure from the edge saying what they want from the network, and the network automatically provide it to them at the edge. Right? Instead of having to have human beings trying to manage the core, VLAN mapping, all that stuff, using this approach, it's simply just the same configuration you would have done, but much easier. And the machines actually tell the network, say, I have 15 new VMs showing up at this server, and they just show up, and the VLAN mapping is automatically done for them. Right? The other issue too is scale. 4,000 VLANs is long, long gone. We're now with SPB up to 16 million virtual LANs. Right? And that kind of scale allows us to be able to say that the edge machine can just simply boot up and immediately be part of any one of those 16 million connectivity. Right?
No.
Why not? Because it's being done right now. That's why we say
Well,
no.
it's being done on the physical side, but the
Yes.
problem is in the virtual network, I have the concept of VLANs, and they have a limitation of 4K VLANs,
Mhm.
internal to almost every virtual switch out
Okay.
there. If
Yep.
I'm going to extend your concept of VLANs all the way through to the VM, let's say,
Mhm.
so that the VM is on the right VLAN, not just blocked at a firewall or something like that, so that I don't even need a firewall, you're still talking physical networking.
No, I think our use case is slightly different. Okay.
I have thousands of desktops. I have thousands of servers. I have 100. Let's think about VMworld this year alone.
Yep, I was there.
250,000 VMs were being booted and brought up and brought down across 3 clouds on countless hypervisors, to be honest.
Yeah. Okay. You're looking at this from the fact that's thinking that you have to stretch VLANs across the infrastructure. To
No,
me,
I'm
VLANs
talking
are
about-
port access only. All right. So.
Yeah, but you just moved the port further and further away from me. I'm never even,
No.
I have VM to VM communication going on that you never see.
Yeah, and I don't need to.
Oh, maybe you do.
All right. Depends on approach. Okay. How much do you know about SPB? Because you're making assumptions, I think, based on traditional Ethernet, not modern Ethernet.
I'm basing it on what virtual machines can do today.
Okay.
networking-wise.
Yeah,
All
we're
right.
wrong. We're completely on the wrong track.
Yeah.
So,
Let's whiteboard a sample topology, if we can, just to walk through all 12
Okay.
applications. Yeah.
Let's just do a simple one first with 2 racks, all right, connected by an infrastructure. Rack 1, rack 2. All right, and say you have a set of switches, routers, whatever, in between, and they feed into a top of rack. Is that good enough? Say in there? Okay. I just want to make sure we're saying the same language, and they connect into that. And then there's a server here with a vSwitch. Is that a picture that you match in your head?
No, actually, no.
Okay, then that's where we're coming from different
that'll be
perspectives.
fine. That'll be fine.
Okay. So I'll tell you what's going on live right now in a lot of different environments, okay? And we're talking about enterprise environments, running their own data centers, right? Okay. So when VMs pop up down here, there's a new ID for VLANs now called an ISID. Are you familiar with an ISID? Okay. So an ISID is 16 million. It's services. It's 24 bits, right, as a VPN address. And today you go in there and you can say configure ISID 20 right here, and then you configure ISID 20 right here, and then there's a LAN between. All right? As far as these VMs concerned, they're sitting on the same switch. They have no idea they're actually separated by a bunch of switches. They think they're on the same switch. All right? That's exactly what's going on right now with vMotions in some really, really large data centers.
Well, vMotion's exactly right, but this
Yep.
is when I'm not talking vMotion.
Okay?
I'm talking the VMs themselves. I don't care about where the VMs
All right.
move to.
Sure.
I'm talking about the networks of the virtual machines themselves.
And I see them all as one.
They're
You're
not
separating.
all as
I
one.
don't.
You can't be all as one because I have, my own infrastructure.
Yeah.
That's in like 20 different trust zones. Believe me, they're
Yep.
not all one.
Okay. No. When I say all one,
And
I mean
I have-
all one problem. The vMotion and where the VM lives, it's subnet, it's default gateway. I'm looking at it as
But
one
I'm
whole
not
function.
looking at where vMotion is not solving that problem for me.
Yeah.
It's solving the vMotion problem, but not solving the other one.
All right, so let's keep going with this for a second here. Let's kind of extend this network infrastructure a little bit here. And I could change colors here for the LAN. So 20 goes to here and here. And let's say you have another rack sitting over here. And more network connectivity, a top of rack, and then the server going up into it. You figure the same ISID 20 out here, and immediately it's on the same LAN, okay? That's great if they're all talking to each other, the LAN, if you need cluster stretch or something like that, right? The point is that you're getting routing between them as well as access to them from the outside world.
Short question for me actually, because I don't know SPB, but is
Yeah.
that core? Is that an L2 core?
That would just be a switch router core, yes.
L2 ECP.
Yeah.
So
Yeah.
conceptually, you could regard SPB in very simplistic terms as an alternative to Trill.
Absolutely.
Technologically, so it's an L2 ECMP core. Now, there's some really neat things about SPB that allow it to scale well beyond what Trill can achieve, and it has some unique features around multicast and the isolation capabilities, because its primary design goals, from what I can see, was it's kind of targeted at Metro Ethernet.
It was one of them,
It was one of
and
them.
large-scale data center.
So it has a bunch of features around isolation and security that are well beyond what Trill was more meant to solve the campus data center challenge. It was meant to be one customer, it wasn't meant to be Trill-like, whereas SPB is more focused in that area, which is why Ed's questions are kind of off base. Ed's more of a server guy, and it doesn't sort of.
Well, no,
Oh,
the main thing is
that's why we're using two different words to explain the
you-
same thing. Okay.
Basically, what you're talking about is, to me, this is all about VM kernel ports, which is really just tied to a single hypervisor. I'm talking about the actual virtual networks inside the hypervisor.
You want to be able to put, a VM on the ID that you're referring to as something.
I can put a
excellent
hy-
ID.
20.
We're not, so Ed, we're not
Right.
talking software networking here, it's just hardware.
I kind of figured that. That's why I was wondering if it extends into the cell for later at all.
So it'll
Or
extend into the
can it?
virtual switch, but that's as far as most likely it'll go. Okay?
It's probably just expands to the uplink, not even into
So I'm
the
saying if you have
virtual switch.
16
It could
million-
actually. There's
you have
some conversations
16
about that.
million IDs. Are you asking, you want to put
But no
a
virtual
VM
switch has 16
on one of those,
million.
16 million LANs, not on a VLAN in the virtual switch?
But none of the virtual switches support 16 million IDs today.
They don't need to.
Concurrently, right? 1,000 v from Cisco, for example, supports VXLAN, but only 2,000 active at any given time.
Exactly.
So it's like
It's a hardware
really big
scale.
difference.
Yeah.
Yeah.
There's a protocol scale and there's a hardware scale, and you always got to make sure you keep those two clear, right? There are 16 million services capable in SPB environment. Holistically, the entire environment could have 16 million in it because of where you separate out the LANs. Will you have 16 million on one device? No. Memory footprint doesn't allow it right now,
That
right?
makes sense.
From a radio perspective of how you configure LANs in different environments, though, they're generally locally isolated, right? They're not spread out everywhere at every moment. And to the hypervisor kind of question, it will be in the vSwitch most likely, right? We're seeing quite a bit of people asking for it, actually.
It'll be in the next vSwitch, which is going to look suspiciously like what Martine built. Because I have a feeling that NSX is going to be the new vSwitch.
It could be.
Well, basically, all of those virtual switches use Open vSwitch. So your
Yeah.
earlier statement, Ed, was incorrect. All of them use vSwitch in the kernel,
Yeah.
whether it's in the VMware or the KVM kernel.
Well, only NSX uses Open vSwitch.
No, all of them do. You're actually incorrect. So
Different
that-
user space agents,
That's
but
right.
the
So they
kernel,
all use the
kernel
Open
is
vSwitch
OPS.
module that's in the kernel of KVM, and then they have the user agent. Which
Well,
sits
yeah,
on
you're
top of
talking
it.
about KVM, but I'm not talking about KVM.
So VMware is the same.
NSX,
They,
yeah.
they basically ported over the kernel space agent from OVS and use that. So,
For NSX, yes.
but
Yeah.
who cares about VMware? VMware is just one virtualization platform on one menu.
And there's
If you're
multiple.
talking about Open vSwitch, I agree with you. Open vSwitch is in every hypervisor
Just
today.
move on.
Yeah.
Just ignore it.
So, no, it's a good conversation, actually. I like this kind of level.
You,
What's that?
you mentioned that SPB has some differences around multicast. And
Yes.
Having beaten my head against a desk with multicast over and over and over and over again,
Okay.
can you maybe go into a little bit about how SPB simplifies that?
Sure. So there's extensions to SPB that allow IP awareness because SPB is just ISIS. It's already has IP built into it, right? But we added a few TLVs to add Ethernet. Now to back up a little bit, because I got to back up in history to explain to you how it happens, because engineers typically want to know how as well as the why. So I'm going to go answer that all at once. So for years, we worked on multicast before we actually worked on a lot of the deployment models in that because we want to get multicast just right. Right? We didn't want to have a world of spanning tree loops and nightmares and all that stuff. And to the point that Greg meant about Trill and the scale aspect, we were intending that SPB would be deployed in colossally large environments. But the intent was that if we build it really large but make it really simple, it'll scale down to the really small environments at the same time. So because we built it for carriers and data centers, the mom and pop shops get all the value of security and separation built in. Right? Because it's got to go in commodity hardware. We're not allowed to build technology on IEEE just for the fun of it. We got to go through a gating process, right, to prove that there's a need in the market, there's a value in the market, it can go to commodity hardware as well as up to really large gear, okay? So we spent a whole lot of time working out multicast to make sure we could load balance traffic properly without fear of loops. So instead of just giving up on that and saying throw a TTL at it, which is basically just saying how big do you want your crater when something breaks, right? We said no TTL, we're going to do the multicast properly, prevent loops from ever happening. Even if a box loses its brain, we want the network to protect itself against that box, right? So it's a little more holistically approach that to deal with the problem that we know is going to happen, right? That is, somebody's going to lose his mind in a network. How do we prevent that from happening or hurting the network? So then we spent a tremendous amount of time doing multicast algorithms for SPB. Okay, why do we have to do that? Bum traffic. You heard of that? Broadcast unknown and multicast. Right? Lots and lots of Ethernet is multicast. So if we can optimize Ethernet's multicast, which by the way, the hardware of Ethernet is some of the most advanced multicast algorithms on the planet, right? Even that little Netgear switch you get's got an incredibly powerful multicast engine built into the hardware.
Right.
So if we took better control of the control plane to set it, we leapfrogging functionality. That was the idea, okay? So fast forward here, we wrote the multicast algorithm. So basically what it does is a multicast Dijkstra, right? All
Okay.
at once. Every node immediately says, when it sees a multicast group that needs to be joined, right? It says, am I on the shortest path? And if I am, lock in state. Immediately. Right at the Ethernet layer, right? There's no reverse RPF, reverse port path forwarding and all that. Tripped over my tongue, sorry.
The 3 dirtiest letters
Yes.
in any multicast development.
Right, so we have in some really interesting environments like Multicast, where we did a podcast with the Packbutcher guys, we talked with a video surveillance vendor, and they are the worst nightmare of multicast routing.
Yeah.
Okay, why? Because you have thousands upon thousands of cameras. Every camera is a source. There's only 1 or 2 receivers, right? And every camera is sourcing multiple groups, HD. Okay, so you have the actual reverse of what multicast was originally designed for, right? And even when it was designed for the reverse, it didn't scale well when you have 1 or 2 receiver senders and multiple receivers. So now we flipped it. Now we just took multicast to a whole level that it's just scary. So because SPB was designed from the very get-go that you can have hundreds or thousands of source edges, all multicasting efficiently, we reapplied that to IP multicast, so you don't need a rendezvous point. You don't need bootstrap router. All you do is you say, okay, I want you to be a multicast edge, and you to be a multicast edge, and you to be a multicast edge, right? Or you to listen to these groups, and immediately when they start seeing sources and receivers in the environment, they automatically detect them and connect them together using a multicast Dijkstra to lock in the state. Now what's interesting about that is that the more receivers there are, the faster it actually delivers the content because the tree's already out there. So let's say you get your source and you have a receiver and he pops up with an IGMP join. Now he says, oh, I know where that group is, it's over there, locks in state. That takes about a couple milliseconds to do, right? Say you write down the tree from him. So you got a source up here and you got network devices and you got the receiver down here and a source up here, right? And the first receiver comes in and it causes the tree to go to here. That took 2 milliseconds, the example I just gave. Now another receiver pops up with an IGMP join. It doesn't have to go all the way back to a rendezvous point using bootstrap router configuration and all that. This node right here just simply said, oh, I see a receiver for that. I know where that group is. I'm going to announce I want to join that group as well. And immediately this node just grafts it on. If another receiver comes up, right over here, same thing, right over. Right? So it makes a really fast and efficient scales really, really nice. Now from a video surveillance perspective, what's interesting is we've had other people do a lot of tests comparing an SPB approach, say, to a PIM approach. The scale is unbelievable in comparison. Like 1,000 groups in the PIM world to 10,000 to 40,000 groups with no errors and 20 millisecond conversions time to the core. Right? So that's just because we spent so much time working on the algorithm to make it work. The nice thing is it's just a different function of SPB. It's not like you're deploying a whole nother SPB to make it work. You just turn it on wherever in the environment.
It's an added benefit.
Yes. So for example, if I connect this network with this network, right, I can have a receiver pop up over here and he's immediately grafted to the tree. Well, at the same time, there are LANs extensions going on, right? And I can do this inside of a VRF too. Right? So it's kind of interesting watching this economy of approaches where a lot of people want all these services and then everyone seems to think, okay, well, the best way to solve this is to keep throwing more headers at it. Right? When we start asking ourselves, okay, what's the best way to solve this? Might actually be go right back down to the base layer, optimize it, and provide connectivity between the sites. Right?
So why isn't this approach taking off in your opinion compared to all the different overlays?
I guess it's a matter of perspective because I haven't been home at all year long this entire year because I've been traveling from customer to customer because it's being deployed all over the world. Right? So from a perspective basis, it's kind of interesting. Now, why?
So let me clarify that.
Yep.
My world tends to be enterprise, not service provider.
And I'm an enterprise. I'm not service provider.
Okay.
In fact, the SPB is 95% deployed in enterprise.
Okay.
Who supports SPB?
Yeah.
What vendor support it?
In May, we did an Interop event at Interop. And we had Ectolucent, we had us, we had Huawei, we had HP. There were 3 other vendors that were going to come but couldn't make it in time. They'll be announcing on their own. I think one already did, but I don't know for sure, so I'm not going to say them publicly. Right? But every major vendor I know has a working prototype, if they're not already shipping it. Right.
And do you see SPB as displacing Trill, whatever Trill might be out there?
2 years ago, I used to do a whole bunch of presentations on SPB versus Trill.
Yeah.
I don't get asked about it anymore. Nobody I know is actually deploying Trill. Right? But I know SPB is deployed every single major vertical in every major country because I've been there and I've worked with them about it. It's going to be running the entire 2014 Winter Olympics, for example, right? Just SPB. So all that multicast stuff, when you're going to be watching the Olympics over the internet, inside the Olympic environment, when someone's sitting there on a video camera, it's streaming IP multicast over SPB, not PIM. Right? So is it taking off? I see it deployed in a lot of places, solving a lot of problems that people didn't even know that they could solve before.
Let me ask you this, because this is something I was thinking about earlier. So you talk a lot about SPB, and there's people that are doing interop with SPB and all that.
Mm-hmm.
And then we talk about Trill, and you say no one's deploying Trill.
Well, I don't know for sure, but I know,
But part of the reason why no one's deploying Trill is because Trill doesn't exist in a form that's usable.
So when I ask about Trill, just to qualify, in my mind, I'm thinking specifically
Fabric Path. VCS.
That's it. It's all
and so,
but those aren't really Trill.
They're Trill with secret sauce.
No, they're proprietary Trills.
Right. So,
yeah.
Moving that discussion to the other side of the fence, is the SPB that you implement the same SPB that, and we'll just
it's all in standards.
Alcatel-Lucent or whoever happens.
Alcatel-Lucent is working everything I know to talk about because we have conversations.
So, and so that'll play nice, and I don't have to say, oh well, I've got to decap all my frames out of VCS and shove them into Fabric Path.
Nope.
That may be your end there. That may be why you're seeing a higher deployment numbers, is because I don't have to worry that Juniper's SPB is completely different than Extreme's SPB. So
in the third, I told you we just went through the fifth interop. I believe it was the third interop, if I can remember my dates, because it's been a few years now, right? And I don't mean interop as a show, I mean interoperability session that we do in standards. A real standard should go through interoperability events. That is, we bring gear from multiple vendors into a lab, we plug it into each other, and say, is it working? If not, coders actually say, why isn't it working? Okay? And we discuss an analysis. We've been doing that since the very beginning with SPB. And at the third event, in a lab in Ottawa, actually, right, I forget whose, but it was in one of our labs, we had multiple boxes from multiple vendors, plugged right into each other, all came right up. There was no work to do on data plane because it's just Ethernet. All the control plane just worked, and all the OANM that has been deployed for many, many years, 201H, AG, excuse me, the layer 2 ping and layer 2 thread, all worked from multiple vendors as well. It took 15 minutes to set that up. We got bored and then did a vMotion over it to prove it was completely interoperable, right? And then we had test vendors come in and start injecting large amounts of fake nodes to start scaling it out, and got it to something like 300 nodes, and then it reconverged. I think there was even a Quagga implementation that was mimicking another 30 nodes, right? So it is completely interoperable and completely standards-based, right? And by the way, we're not recreating the entire standard again like Trill's doing, right? That's all other thing they're doing right now, because they're recreating this thing. They're trying to reinvent an ISID or something like that, right? Does that make sense?
It does.
Okay.
Yeah. It shows that there's a lot of maturity there.
Oh, there's a tremendous amount of maturity. And it's not even just the maturity of SPB itself, because we didn't change ISIS. We added on to ISIS. So all that maturity that the carriers had beaten out of it for the last 30 years is still there. And we just reused it, right? Now the configuration of it is mind-numbingly simple. That's the one response I get from a lot of people. In fact, that same podcast referring to, one of the gentlemen from another company mentioned, he goes, oh, I couldn't believe it. I couldn't believe that was it. Right? That's all I have to do. So when I refer to, I have a network of several hundred switches, switch routers and all that, and I want to extend the LAN from rack 1 to rack 530, all you have to do is walk over to rack 1 and type in ISID 1 VLAN 7 and walk over to rack 530 ISID 1 VLAN 52, because you can rewrite the VLANs. They're locally significant, right, per port, right? And the LAN's automatically extended. And this is underneath another routing protocol. So you can have OSPF running on top of this for routing, right? Or you can use SPB for the routing because it's got ISIS and routing, right? So if the vendors reuse the IP, they can do that.
Actually, that's something I wanted you to explain in more detail. You said that before, that, he can do the routing for you. It's like, does he mean layer 3 routing, or does he mean layer
I mean
2
actual
routing?
layer 3 routing. Because it's ISIS, it's had IP routing capability for decades.
Understood, which in this context, I've only assumed it was used for routing MAC addresses.
We purposely wrote the SPB specs so that we did not limit an SPB environment ISIS to only be doing SPB. SPB is a service of ISIS, just like IPv4, IPv6 is a service of ISIS, right? So, for example, in very simple terms,
what would be a common topology in a data center in terms of, leaf spine?
Leaf spine. You know what's funny is that we find that when the data centers are deploying SPB, they find that leaf spine is a very inefficient connectivity model. right? And they use SPB to give them better connectivity models for vMotions, for socket calls between databases and web servers and app servers.
Leaf spine is inefficient.
Yeah.
Don't tell the rest of that.
Okay.
The reason I asked, going back to Ethan's question on L2, L3, how many L3 gateways can you have across the spine? Was my next question.
I honestly don't care how many you have in our environments, right, that we see with SPB. Because, and I'll say that reason why is that I can spin up multiple VRFs, and each one could be a default gateway for a different virtual network. I can, the kind of...
I'm talking about a single virtual network.
A single network running that. Then you have as many number of subnets as you have in an environment. Because you can spread the default gateway to different boxes.
Could you do like a 4-way VRRP?
Sure, if you actually had the code written to do that, yes.
Well, I'm saying, so right now, what would you support in that design?
Most boxes I know only do a 2-way VRP,
Okay.
right? Most vendors I know only do that, right? So,
And GLDP or HSRP, right?
sure, they can do that on top of it. It's just a LAN. Let me focus you a different perspective, right? Think logically, not physically. Because if you come from a VLAN IP world, you think you're thinking logically, but you're actually thinking physically.
I want to know how much HA is built in from an L3 perspective.
Yep. As much as the vendor puts in. That's what I'm trying to say. Oftentimes people think they're thinking logically, but they're not.
From a north-south L3 perspective.
I know exactly what you're saying.
Okay.
All right, so assume you have, let's keep this really simple, 2 boxes, right? And you've
What's
got
your for a spine?
spine as in you want 2 and then 2 dual homed?
No, I'm saying you have 10 racks and a 4-way spine.
Oh,
So 10 top of racks, which is multi-homed into 4 and then it's fine there. Yeah.
okay.
You can draw 2 racks, but I just want.
Thank you. I was wondering where you're going. Okay, you want 2 core,
4.
4 core, like this.
Yeah, there's your spine. And,
Okay, then you want a bunch of top of racks.
yeah.
So is this common design you see? It's interesting that you say leaf spine isn't efficient. That's
And you want something like this, right?
topic altogether, I guess. But.
Is that what you want?
Each top of rack would go all the way to
Yeah.
the,
To all 4?
Yeah.
Okay.
Well, again, this is what I want to hear from you, what you're seeing out there as well in the data center.
The nice thing is that SPB, when it's being deployed, it's a software upgrade to the existing switches. Right? So whatever topology is there, it just reuses the topology. And it sees all links at the same time. Right? So if it sees 4, like in this example, because there's 4 links going this way and only 2 going down, it sees it has 2 equal cost paths to go there, and then will load balance across the 2 paths to get there. Okay? Now, if it was this, it's going to see it has 4 paths to get there, see all links, and load balance all the traffic from end to end. Now, additionally, on top of that, there are vendors that not only do that, but they also support dual homing into the server. Right? And this is a high availability functionality, multi-chassis lag, active-active. Right? We have this deployed right now too as a vendor. Right? So we have multi-chassis lag going into this layer. The server thinks it's got one link, lag link going up into the core. Then it's also load spreading out here across the infrastructure for a LAN extension. Right? Now, that's physical though. What's the logical is really important here to put the link away. Let's talk about LAN. Right? At this point, if I could figure a service here and here and here, and they're on 3 points, right? Logically, what I have now is something like this, where I have server, and I might have a default gateway, right? Sitting up here. The default gateway can live here and here. It could live here and here. I don't care. It's logically floating over the layer 2. So just like you have the OSI model where IP is over Ethernet, you think exactly like that.
So what you're saying, are you saying pick any 2 you want?
Yes.
Default gateway?
Yes. For any given LAN.
No, and I'm okay with that. But
Yeah.
So it's, again, I think, right now, again, I work a lot with a big vendor out there, and 4-way HSRP is sort of, coming down, and then Unbehagen, right?
Yep.
Be able to deploy, default gateways across all your spine, not really doing it on any 2 of, of n number. And so I was just curious if you can have your default gateway across all 4 spines.
Mm-hmm. Yeah, you could do that too.
So the answer is no, I guess.
No, the answer is yes if the vendor, like the 4-way HSRP is a Cisco implementation of a particular feature of HSRP, a non-standard dual float, right?
Sure, understood.
VRP, right? You can have a dual or 4 if someone's done it. We do a 2, but we do a split. Instead of actually doing VRP, we actually do what's called a routed multi-hop. That is that every node that's participating as a virtual default gateway will pick up the thing even though they're not officially the VRP master, right? So that way we get what you're asking for without having to send a whole bunch of messages across the LAN, right? Because it's a whole lot of noise for no reason. right? So that's what I say. It's not a simple. Do you do a 4 or 6 or 2, right? There's other ways of solving the problem. You know?
Yes, sir. SPB does not introduce anybody can ARP for that local gateway. You're still dealing with physical boxes in the mesh that need to be the ones who are going to respond.
No. Yes and no. So let's back up a second and agree on one thing. Every switch sold in the last 5 to 7, maybe 10 years is a switch router. Has routing code on it as well. So you have 2 different state machines. You have a switching function and a routing function. And logically, the routing function plugs into the switching function, right? So inside this box, for example, if I want to do this LAN extension, right, and say it's flowing through these boxes as well, I can have a virtual port plugged right up into that routing instance. Okay? He's sitting on that LAN. The routing instance is sitting on the LAN up here, right? And I can go over here and say, I want this routing instance plugged into that as well, right? So now the LAN access point, this server, right, thinks it's sitting on the same switch as the routers themselves. Now that doesn't stop you from having a pure router plugged off this device, right? And its ports plugged right into that LAN at the same time this virtual one's plugged in too, because it's just a VLAN at that point. Everything is VLAN attached to the virtual LAN extension, right?
So in this scenario, the server pops up and says, "Oh, I need my default gateway." Puts an ARP on the wire. Who responds?
Whoever is the local default gateway will respond on it, because it's as far as the routing instance, whether it's this virtual routing instance sitting inside the code or this real router, he's on a LAN. So the same ARP response process would happen the same way it has for the last 20, 30 years.
And if we don't define a defend?
If you don't define what? Like a default gateway, you mean?
Yeah.
If you don't define a default gateway, but a real default gateway here, but you configured one down here, then normal IP ARP will say no one answers.
What's I'm talking about? I had to find a default gateway somewhere,
Mhm.
one of those, but I don't have a external router. I have just those switches.
Okay, and that's where I said every box for the last 10 or so years has been a switch router.
Yeah, I understand.
So normally what you find in all deployments is the routing instance is actually like this. There's a routing instance inside the switch. So it's doing a layer 2 pass-through for some services and routing functionality for other services. So for example, I might have a different interface, green going out for the north-south traffic.
Rather than theoretical, I think you get the router on a stick and it makes sense, but just
Actually, this is a real diagram from a real customer, right, too. And by the way, that same customer, what he ended up doing, to get your point about leaf spine not being very efficient, right? They started doing this.
yeah, you know, if they want to do that, you know, and so they
Well, it allowed some interesting things from the way they were looking at research about traffic flows. Is that when servers want to talk to each other, it was far more efficient to use low-cost ports and really high bandwidth, terabits upon terabits of aggregation bandwidth between, to go this way for cross-app traffic, so web app database, and then they went up just for north-south. Right? Really efficient from an application flow perspective. It's really interesting when you start getting, when the app guys will talk to the network guys and they'll sit down together, you can find out some really cool things about a network, right?
I just don't like talking to people. They're like demanding resources, and I want it now.
Yeah, not all environments are like that. I've seen some really good environments where engineers are trying to solve a real problem, right? And when they all sit down together, you can find out some pretty cool things like this. Right? There's some phenomenal research actually on that. I think that was put out a few years ago by several researchers who might now be working for a very large service provider hosting company.
You know, I've read some PhD thesis work too in terms of, you know, how to best cable environment with, again, SDN controllers, optimize what flow should go over which links, and you cable however you want, and it'll optimize it. But I guess I'm asking for, I guess, the average enterprise, you know, what sort of the design pitch, you know, is it leaf spine, and then take 2 of your 4 spines and configure your
Typically what happens, because these are going in existing environments, it's already a leaf spine, okay? And then because it's a fabric in the real sense of a fabric, that is that every link is known about, there's no spanning tree balancing, all that kind of stuff going on around there, right? Or RSTP or MSTP, it's just SPB. Because it can see every link, you're no longer limited by where you put the links. People start looking at that application flow, and then they start adding these cross links in different directions than a normal leaf spine, because they can just connect a fiber in anywhere. They're not limited by racks or, you know, running a building, you know, silos here. So that's oftentimes what starts happening is they start deploying these things. What I find really interesting is when I start seeing deployments out there is people start trying to use the ISIDs the same way they've always used VLANs. And then they do that for a little while, and then they realize, wait, I can do this anywhere I want at any moment. And they'll walk over to it several hundred racks away and configure the LAN and watch it appear. That usually shocks them into reality of, I'm not limited by network.
Equivalent of VTP in a larger.
Okay, yeah.
Right.
Equivalent of VTP, but
But
you're not limited by timing, scale, or a vendor, right? It's cross-vendor kind of thing. All right,
But an ISID is not a VLAN. Why don't you just define an ISID?
that's true. So an ISID is an individual service ID. So in the past, we were all taught that VLANs were, HR department, engineering department, like there were VPNs. The problem is that's not really what VLANs are. Right? A VLAN is a sub-topology of a physical topology. But once it goes up to the IP layer, everything's normalized if it's all in the same router, right? So what people really wanted was a real VPN ID extension. So instead of mapping out a VLAN from every ingress port to egress port, span tree access, an ISID is a VPN ID. It's a service pinpoint at individual points. So that the protocol says, okay, I see where those VPN IDs are, and I'll connect them together in the most optimal forwarding path. Okay? So if the network is leaf and spine today, it'll use a leaf and spine topology. If you start connecting, say, for example, I want to go from this switch to this switch, and today I can only go up and down, and I add that link between, and it's the same speed or more, immediately the protocol is going to say, swap, go right there, and you didn't have to be involved at all. You just plugged in a link. Sure. Right? So that's a lot of flexibility. Now the routing aspect on top of this thing is what's really important because we don't live on the same LAN as our servers, right? It's this north-south functionality, being able to do it into the virtual router as well as being able to do it between multiple LANs, right? So red, sitting here as well, here and here, is now going here down, as well as up and through, and this guy is also sitting on side the red LAN, right? And he's also on the green LAN going out, so that's 3 subnets right there. Right? You got your north-south traffic coming in. You've got your east-west for, say, blue is the web servers and red is the application servers, right? And assume there's like green and orange and all that stuff for like database and things like that, or a vMotion background or something like that. That actually is the most common deployment out there. What you're seeing right there. Now, the LAN extensions, typically what I find is that the link going up to here is only for the north-south. Because people start putting these cross-links in directly between the top of racks, and they use the bandwidth, you also see the spread come out. So if I configure the red here, it'll come across and down, and this guy will also have connectivity. You'll see fib state in those different places. What gets interesting about this is that because SPB is aware of link forwarding ability, as well as service placement, that is where it is in the network, it only installs fib state where it needs to be. So if I walk over to this switch where none of these services are, you'll see none of that fib state there, right? Why would you? It doesn't belong there, it doesn't need to be there, so don't put it there. It only exists on the shortest path between these end nodes. So when I'm sending traffic, say, from a device, because this is also interesting, you see dual homed, but you also see single homed off the same device, right? So if I'm sending traffic from this guy to here, 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 and say here, right? It's going to take this way down, and up and over. It's always going to take the shortest path based on the source's view of the network. So the shortest path from me to you will be the path I take. The shortest path from you to me would be, but you won't take my path to Ethan. You'll take your own shortest path, and I'll take my own shortest path, right? So it's the same reason why in IP multicast, most IP multicast environments move to a shared tree, and very quickly as they can possibly get, they get to a source-specific tree, because it's the most efficient to the network resources. We just started there with SPB. But we made it all hands-off in the background, done.
It's cool, and the flexibility is great with any L2MP, proprietary or not. There's some flexibility with plug-in cables.
Mm-hmm.
A lot of enterprises want structured cabling in terms of, hey, you know what, the cabling actually goes north-south, so leaf spine makes sense to start with.
Yeah.
If you find out some top flows are between 3 racks, you know what, cable them directly, and you're cool.
You
But
just said exactly what happens.
Just to clarify, I guess, the one point around L3 gateways, you're still here leveraging VRRP for that gateway. Is that accurate or no?
It depends on the vendor. And I'm trying to talk both not only as me as a vendor, but also for other vendors who are implementing this, okay? So for me as a vendor, we can use VRP, or we can use a more efficient model where if I have all 4 of these sitting on the same LAN, right? I don't necessarily have to send VRP across the LAN. I can just simply say, I see somebody who's looking for the default gateway, and I am configured to be the default gateway as well as these other 3, and I'll just forward. I'll pick it up off the wire.
You can do a shared IP and MAC address.
Absolutely.
Yeah. That would be your receiver sauce.
That would be ours.
Okay.
Other vendors would just simply run VRP on it.
Okay.
Right? Because the same thing would happen, say you have these 2 boxes like this, assume they're normal switches, these guys could be running VRP on this LAN transparently too,
Absolutely.
right?
Absolutely.
It's complete
Can
flexibility.
You router, you know, yeah, of course.
It could be an MPLSP as far as I'm concerned,
Yeah.
all right?
Okay.
The whole point was saying we don't want to force people into having to do this. It's take every possible combination that we've done for the last 20 years of Ethernet and IP and make sure all of it can work together, right? So that if someone, in fact, actually we did this at VMware last year, we showed that with the IP multicast functionality, we could scale VXLAN orders of magnitude farther than regular PIM. Because it's just IP and Ethernet at the end of the day. Make sense? Okay. And I agree with your recabling thing. You've actually hit it dead on with your cabling example. The hub and spoke is there, and then they find out that these 5 racks there's a whole lot of communication, so why am I using a very expensive port and another expensive port when I can just plug them directly to each other and the traffic starts becoming normalized? And then that box's CPU and port utilization drops considerably, right?
Any last thoughts?
There's many, many ways we can go. We went really down a rabbit hole in the data center and all that stuff.
Well, you guys are Avaya. Why don't you map this technology to the actual Avaya product set?
So the Avaya product set is interesting. So I joined Avaya about 2.5 years ago, and I've worked in service providers, I've worked in ASPs, and I've worked in enterprise and other vendors, right? All through actually working on SPB as well. What's interesting is I was surprised actually how far ahead these guys were when I first joined. I mean, they're like years ahead of implementing SPB. They just believed in it and full bore went into it, and I was impressed. Now, the Avaya product set, most people don't realize, is actually out of the Nortel set. So when Avaya bought the Nortel assets, they not only bought the voice assets, but they also bought all the data assets, right, for the enterprise, right? And what's interesting about that is that meant that we have millions and millions of Ethernet ports deployed around the world from that heritage. And most of them are still customers of ours, right? So we have a full-fledged product line going from the closet stack to the topper rack to the core switches to edge branch routers and all that functionality. And SPB is almost on every single product now.
So are you saying that you can do SPB on like an old BPS 2000 or base stack, or is there?
Well, I don't think they don't sell that anymore.
Maybe not that old, but you're saying you can do it on your traditional campus switches as well as data
Well,
centers.
there's a silicon dependency, right? It's got to be baked into the ASIC
Yeah.
to do this.
Yes and no. The core functionality, no, because that's just Ethernet switching. The edge functionality of doing the Mac to Mac function, yes. All right. So I would say a good number of the actual installed base that is running SPB, that when we converted the installed base, it's the same switches. Now, if they were running like a 20-year-old or a 15 or a 10 or 8-year-old switch, and I have found actually there are people running switches from like 1994. So we upgraded them, right, for obvious reasons, because CPU and memory, and we weren't supporting their code base anymore, right? Once you upgrade it, it just worked. The core didn't even, in fact, many customers, we went out and upgraded some of their edges, and did a software upgrade on the core, and they had SPB, because it's just Ethernet. And that was one of the things that's required of the IEEE, is that when you do something, you can't orphan the last 30 years of technology. You got to make sure you bring all that technology forward with you, right? Now, and by the way, what I'm referring to here is SPB in general sense. There's actually 2 modes of SPB. There's SPB-V and there's SPB-M. Okay, so SPB-M is what we refer to a Mac and Mac functionality, and then there's SPB-V, which is VLAN orchestration, basically like Q and try to control VLANs. I don't know of a single vendor who's done SPB-V, because once you actually step back and compare the two in functionality, you realize SPB-M is far more efficient and scalable and capable of doing things that a Trill or SPB couldn't do, right? And you do it all at line rate. What's interesting to the point, like even Ethan looked a shock when I said 95% of all deployments of SPB are enterprise, because everyone thought that, hey, this is a carrier protocol, why would enterprise use it, right? The reality is that enterprises love it, and I haven't seen 0 uninstalls of SPB. In fact, almost all installs that I'm personally involved with, and I know of from other people, once they turn on SPB, they immediately went whole hog into it and actually extended out faster than they had planned because of the simplicity and agility, right? There's this pipe dream about being able to configure a LAN here and configure a LAN there, and it automatically happens and all that, and not being able to do it. It doesn't matter what's under the covers. The point is it provides that flex and agility for the end enterprise, and that's all they want.
Are the enterprise deployment go beyond the data center? Because
Yes.
I think we focus a lot today on data center
Thank
side,
you.
but I was thinking about
Thank you.
Edward pointed out earlier in the different section that we want to go all the way to the campus network, even down to the user
Yep.
edge. right? So how is it deployment?
So
Go
the
beyond the data center.
example, Interop last year, not this May, but the May before, I presented that one of the first deployments of SPB from a year or two before that was the Oslo medical system. All right, they run SPB from the closet where the MRI is all the way to where the server for it is in the data center, and they keep them isolated in VRFs as well, from edge to edge. I know there's transportation environments that do this in the subway systems, to the conductors, all the way back to the servers back in the data center. That's the important thing, is that we don't see SPB as being a data center technology. It's an Ethernet technology. Where is Ethernet? Ethernet's everywhere. It's
Yeah, I would
even
be
in
more
your car.
surprised- I would be more surprised actually if more of the customers want it for campus use cases.
Yeah.
I've seen some crazy applications in education and hospitality that they need L2 adjacencies
Yeah.
between the applications, and
Three of the-
again, it's crazy to get it done, but it's possible, and this would be very beneficial.
Three of the
Yeah,
largest
that-
installs of
like-
SPB are in education.
What's
Three of the
smallest-
largest.
What's the smallest installs you guys have done?
The smallest?
Yeah, how many? How,
2 switches.
2 switches? So you scaled all the way down.
2 switches
Okay.
on 2 topper racks. Right?
So you scaled it all the way down.
All the way down. Doesn't matter. It goes right down to it's running on a 12-port 1U box right now, as well as a multi-chassis, big BFR.
Okay.
Right? And that was the intention, right? Scale it any kind of radix kind of approach. Right?
Awesome.
Yep.
Well, I think that's just about the end of our time.
Okay, no worries.
Paul, thank you very much
Yeah,
for
my pleasure.
everything. We really appreciate it.
Mm-hmm. Yeah.
And, Fidelity,
Thank you.
thank you.
Thank you. See you guys.